This is the video for graphing rational functions review. It should be the 4-question review that you started on in class. For number 1, remember I always tell you to start with your HAs. So with the HAs, we're looking for degrees. On top, the highest degree is a 2. On the bottom, the highest degree is a 2 as well. Whenever the degrees are the same, then we're looking at their leading coefficients, which means the number in front of them. So the number in front of the top x squared would be that invisible 1, and the number in front of the bottom x squared would also be an invisible 1. Won't always be 1s, there could be numbers there, but in this case they do both happen to be 1. So the HA we write as an equation of y equals, and we would set it as 1 over 1. Well, that's just 1, so the HA is y equals 1. So now let's go ahead and move that on our graph. So since that's the horizontal asymptote, we're going to draw a dotted line across at y equals 1. Now we move on to the second part to look for, which is the y-intercept. The y-intercept we find from the end numbers, the numbers that are all by themselves, which in this case is a minus 4 over the negative 12. Well, we do know that two negatives will make a positive, and 4 over 12, you can divide them both by 4. And that gives you 1 over 3. When we write the y-intercept, it's an ordered pair. Since it's the y-intercept, the first number is always 0, and then the second number would be 1/3. And let's go ahead and put that on the graph as well. 1/3 we're going to have to estimate as best we can, which means it's just a little past 0 on the y. Now we look for our holes in our VA. Remember, in order to find holes in VAs, you have to go back to your original fraction and you have to factor. So I look at my top, x squared minus 4. Well, that's one of those special ones because x squared becomes x and x. 4 breaks down into 2 and 2. And then you have a plus 2 and a minus 2. On the bottom, we're going to use Santa hat here. So we're looking for factors of negative 12 that add up to the positive 4. And those would be factors of 6 and negative 2. So our parentheses would be x plus 6 and x minus 2. And again, we know it's them because 6 times negative 2 is negative 12, and 6 plus negative 2 is positive 4. So we take each factor of the denominator for holes and VAs, and we set them equal to 0. So x plus 6 equals 0, and x minus 2 equals 0. Well, if x plus 6 equals 0, we know we take the opposite of that to solve, so we would be subtracting 6, which means x equals negative 6. Since it's x minus 2, the opposite of a minus 2 is a positive 2. So here are my two x values. Now, to determine if they're holes or VAs, we go back to the fraction, and we see if anything crosses out. Well, the x minus 2's would cross out, leaving me with the fraction of x plus 2 over x plus 6. Since the x minus 2 cancel out, I look at their answer, which is 2. So I know that that goes in the whole spot. Since the x plus 6 is still there, that means this one goes in the VA spot, and we leave the VA as an equation. Now the holes are where we have an extra step. In order to find the hole, we have to have the ordered pair. I currently know the x value, which means I'm left to find the y. Well, to find the y, we go back to our original fraction that we've simplified and reduced, and we plug in each x with our number, which in this case is 2. So we're going to go two plus 2 over 2 plus 6. 2 plus 2 is 4. 2 plus 6 is 8. And that reduces to 1/2. So I know my whole is at 2 and 1/2. So now ahead, let's graph those two parts. The whole is at 2 and 1/2. So that means to the right 2 and up just a little bit past that 1/2. Now remember, a whole, while it's an ordered pair, it is not an actual dot because it's a whole. So we draw an open circle. And now my VA is that x equals -6. So that's a vertical asymptote, so a vertical line. And now the last piece of information we have to find is our x-intercepts. X-intercepts we find from top. So I look at my fraction that I've simplified, and I look at what's on top, which is x plus 2. Since there's an x on top, I set it equal to 0. Opposite of a positive 2 is a negative 2. So I know the x value is -2. X-intercept we write as an ordered pair, -2, 0. So now we plot that point as well. So now I can go ahead and sketch my graph. The right side, I've got 3 points here. So we know it's going to curve to the asymptote on the horizontal one, and then curve to the vertical one. But I also need my second graph because these always have 2. So I know my graph has to be somewhere over here. So I'm going to pick this x value because it's just 1 over from the asymptote, and I know it's in the region where I need to figure out my graph. So if this value is -6, that means this value would be -7. And we take that -7 and we plug it back into here to figure out what the y value would be. So it's going to be -7 plus 2 over -7 plus 6. -7 plus 2 is -5. -7 plus 6 would be -1. 2 negatives would make a positive. So my ordered pair is -7, 5. So I'm going to plot that ordered pair. And I know from this point it's going to curve to that red line and get a little bit closer to the green line. And there's your graph for number 1. Number 2, same process. So again, the first thing that I recommend starting with are your HAs. HAs, remember, we're looking at the degrees. Highest degree on top is a 2, on the bottom is a 2. Since they're the same, that means we're looking at their leading coefficients, which in this case are both 1s again. So we have y equals 1 over 1, which is just y equals 1. So let's move on to the graph for that one. After we find the HA, the next step is your y-intercept. The y-intercept are, again, those values all by themselves at the end. In this case, a positive 4 and a negative 8. Well, 4 over 8 can be reduced to 1/2. The negative 8 makes it a negative 1/2. Y-intercepts we write as an ordered pair, 0, negative 1/2. So now let's put that on the graph. So 0, negative 1/2 means just below the 0. And there's my first point. So now we've got two things graphed on here. And now we go for a third thing, which are your wholes and your VAs. Remember, for your whole and VAs, you have to factor. So we're going to go back to our fraction. On top, we've got 1 times 4, which is 4. It has to add up to negative 5. Well, in order for it to multiply to a positive, but add to a negative, they both have to be negative. So that's going to make it negative 4 times negative 1. So on top, my parentheses are going to be x minus 4 and x minus 1. Then we're going to do the Santa hat for the bottom. So this one I've got negative 8 that add up to negative 2. Well, this time it's multiplying to a negative. So you're going to have one positive factor and one negative. To get to a negative 2, we need the factors of 4 and 2. Since the 2 is negative here, that means the bigger number has to be negative. So this is going to become x minus 4 and x plus 2. So wholes and VAs, we look at the bottom and we set each of the bottom factors equal to 0. So x minus 4 equals 0 and x plus 2 equals 0. Well, if x minus 4 equals 0, the opposite of minus 4 is a positive 4. And the opposite of a positive 2 would be a negative 2. So now to determine if they're wholes or VAs, I go back to here and look for something to cross out. Since these cross out, that means that value is a whole value. So I'm going to put it the 4 for the x, and my remaining fraction is now x minus 1 over x plus 2. The other denominator value is going to be an asymptote. Well, with the whole, once I have the x value, I have to replace it and find the y. So remember, we go back to the fraction we simplified, and we replace each x with that value, which in this case is 4. So we have 4 minus 1 over 4 plus 2. 4 minus 1 is 3. 4 plus 2 is 6. And that simplifies to 1/2. So my whole is at 4 and 1/2. So now let's plot the whole and the asymptote. So 4 and 1/2. Remember, wholes are open circles. And the asymptote was at negative 2. And now we go back to find our next piece of information, which is the x-intercept. Remember, the x-intercept deals with just what's on top. On top, I now have just x minus 1. There's an x, so I'm going to set it equal to 0. So if it's a minus 1, that means x is going to equal a positive 1. So our x-intercept is at 1, comma, 0. Let's go ahead and plot that on the graph. So I know that it's going to curve to the green line, curve to the red line, and we've got a hole, so there's a little break there. But again, I have to have two segments to this graph. So I know if I have the graph here on the right, I've got to find out the graph on the left. So I look at my asymptote, which is negative 2. So I'm going to pick -3 so I can see where this point's going to go. So I'm going to create a table. And again, I'm using the x value of -3. Well, whenever I'm trying to find the y, we plug in. So I plug in to my simplified fraction, the -3. So we go -3 minus 1 over -3 plus 2, because of the x plus 2 on the bottom. -3 minus 1 is -4. -3 plus 2 is -1. And two negatives make a +4. So I'm looking for the ordered pair -3, 4. So -3, 1, 2, 3, up 4. And again, this is just enough information to tell me how to make my curve. And there is graph number 2. Moving on to our third one. So again, hopefully by now we're recognizing that we're going to start with our HAs. We're looking for our degrees here. The highest degree on top is a 2. The highest degree on the bottom, well, there's just an x, so we know it has an invisible exponent of 1. So the degree is bigger on top. Anytime the degree is bigger on top, the answer is none. There is no HA, so we don't even need to draw it on the graph. So now our second step is for the y-intercept. The numbers that are by themselves without an x's are the 3, that's positive, over the +3 on the bottom. 3 over 3 is 1, so my y-intercept is the ordered pair 0, 1. So let's plot that point on the graph. So now we're on to our holes in our VAs. And remember, every time we look for those, we need to factor. So I look at my top, x squared plus 4x plus 3. So we're looking at Santa hat for the top. 1 times 3 is 3. Factors of that add up to 4. Well, the only factors of 3 are 3 times 1. And 3 plus 1 is also 4. So we have x plus 3 over x plus 1. On the denominator, all we have is an x plus 3. There's no GCF. X only has an exponent of 1, so that means it's completely factored. Well, since there's only one thing in the denominator, that means there's only one whole or vertical asymptote. So I take the x plus 3 and set it equal to 0. Well, if it's a +3, that means x is going to equal a -3. So now the question is it a whole or is it a VA? Well, when I look back at my fraction, the x plus 3's would actually cancel. So I know that that -3 value is part of my whole. Since I don't have anything else in the denominator, you can look, the denominator's all gone. I know there are no VAs. And my remaining fraction up here is just the x plus 1. You could put it over 1, but having a denominator of 1 doesn't do us any good, so we just leave it x plus 1. So now I take my x value for my whole, which is -3, and I replace it with this x to find the y value, which is -2. So my whole is at -3, -2. So I'm going to go ahead and graph that. Make sure the whole is an open circle. And our last piece of information is our x-intercept. Well, the x-intercept comes from whatever is left on top. What's left on top is an x plus 1. So we're going to put x plus 1 equal to 0, which means x equals -1. X-intercept we write as an ordered pair, -1, comma 0. So I graph that. Now, since I don't have any asymptotes, there's no curving that I need to do here because we only curve towards those lines since they can't actually cross it. So when I have no asymptotes, vertical and horizontal, I know that I'm going to have a straight line connecting those points. Now remember that hole, it still connects to the hole, just doesn't go through it. And there's the graph for number 3. Last problem of the day. So we look at starting with our VAs, our HAs. So we start there. Well, I'm looking at my degree on top. It's just an X, so we know it has an invisible 1. Degree on the bottom is a 2. Whenever the degree is bigger on the bottom, we know our horizontal asymptote is y equals 0. So let's put that on the graph. The next thing we look for is the y-intercept. Again, y-intercept, we're looking for our constants that don't have a variable. And in this case, it's a -1 on top and a +3 on the bottom. So -1/3. Well, I can't simplify that. There's only one negative. So our y-intercept is 0 and -1/3. So let's plot that point. So that's just going to be a little bit below 0 on the negative side. And now step 3, we go to our VAs and holes, and this is where I have to factor. So x minus 1 on top, there's no GCF. X has an exponent of 1, so that's completely factored. Moving on to the bottom, we're going to use Santa hat here. So we have 1 times 3, which is 3. And they have to add up to factors of 4. Well, that's going to be 3 times 1. So we know our parentheses on the bottom will be x plus 3 and x plus 1. Well, to find our holes in VAs, remember we look for the denominator, and we set each denominator equal to 0. So x plus 3 equals 0, x plus 1 equals 0. Well, if it's a +3, that means it's going to be a value of -3. +1 will be a value of -1. Well, I look in my fraction. Did anything cancel out? The answer is no. So I have no holes. And that means both of these are vertical asymptotes. So we're going to draw these two vertical asymptotes on our graph. X equals -3. And x equals -1. This is the one that we've got the 3 graphs that we have to create. Okay, so it's the little bit more complicated one. So now we need to find my x-intercept. I look at what's on top that hasn't been crossed out, which is an x minus 1. So if x minus 1 equals 0, x equals a +1. So the x-intercept would be 1, 0. And we'll go ahead and graph that. So I know what the right section looks like. It curves this way, and it curves towards the y equals 0. Remember, the horizontal asymptote is okay to cross in the center. It's not okay to cross it at the ends. It reaches towards it. It's more of a asymptote for the ends of the graph than the middle. Well, now I know I need a section here. I need a point in here. So here is -1, here's -3, so I'm going to plug in -2 for x. When I plug in -2 for x, I'm plugging it back into this fraction. It's a little bit bigger than the others because nothing canceled out. So on top, we go -2 minus 1 over -2 plus 3 on the bottom for the first parenthesis, and -2 plus 1 for the second parenthesis. -2 minus 1 on top is -3. -2 plus 3 is a positive 1 times -2 plus 1. I know that looks almost like a 4 there, but it's -2 plus 1, which is a -1. Well, that means -3 is over -1, and two negatives make a positive. So we're going to graph the ordered pair with -2 for x and +3 for y. So we have -2 and then up 3. From this point, I know it needs to curve towards the asymptotes, and it can't go below this. So it's going to go up as a parabola. So we have the right of the graph, we've got the middle of the graph. So now we need the left section. Well, the left section is going to be a mirror image of this. So we're going to go ahead and just sketch what that would look like. So I know it's going to have a point right around here, curve towards this one, and curve towards the green one. If you wanted to be more exact, you could take the value of -4, put it into a table to find this exact point, but again, we're sketching the graph, so I'm quite happy with you just mirroring what that graph looks like. The one thing is that I didn't do very well. It should actually kind of go like this instead of this one going down. And there are your 4 review problems for graphing rational functions.